Introduction to Microsoft Excel 2019. Microsoft Excel 2019 is a powerful spreadsheet program used for organizing, analyzing, and storing data in tabular form. It is widely utilized across various industries for tasks ranging from simple data entry to complex financial modeling and data visualization. Understanding Excel's core capabilities is crucial for anyone working with data, as it provides tools for calculations, data management, and reporting. This version, Excel 2019, introduced several new features and enhancements, improving user experience and analytical power. Familiarity with its interface and basic functions forms the bedrock for advanced spreadsheet proficiency. It enables users to transform raw data into meaningful insights, supporting informed decision-making. Excel's primary function is to manage numerical data, but it also handles text and other data types effectively. Its grid-based interface, composed of rows and columns, allows for structured data input and manipulation. The program's versatility makes it an indispensable tool for budgeting, forecasting, project management, and scientific data analysis. Learning Excel 2019 will equip you with essential skills for both professional and personal use, enhancing your efficiency and analytical abilities. Mastery of Excel can significantly boost productivity in any data-driven role, making it a highly sought-after skill in today's job market. Understanding the Excel interface. The Excel 2019 interface is designed for intuitive navigation and efficient data management. At the top, the ribbon organizes commands into logical tabs like Home, Insert, Page Layout, Formulas, Data, Review, and View. Each tab contains groups of related commands, making it easy to locate specific functions. The Quick Access toolbar, located above the ribbon, provides customizable shortcuts to frequently used commands. Enhancing workflow speed. Below the ribbon, the name box displays the address of the active cell, while the formula bar shows the content or formula of that cell. These elements are crucial for understanding where you are and what data you are interacting with. End. The main workspace consists of a grid of cells, organized into columns, labeled with letters A, B, C, and rows, labeled with numbers 1, 2, 3. Each cell is identified by its column letter and row number, forming a unique cell address. Example, A1, B5. At the bottom of the window, sheet tabs allow you to switch between different worksheets within a workbook, and the status bar provides information like calculation results or active modes. Understanding these components is fundamental to effectively using Excel for any task, as they form the primary interaction points for all data operations and analyses. Navigating worksheets and workbooks. Navigating effectively within Excel is essential for managing large datasets and complex projects. A workbook is an Excel file containing one or more worksheets, which are individual grids for data. You can move between cells using the arrow keys, tab key, enter key, or by clicking directly with the mouse. For faster navigation, keyboard shortcuts like Control plus arrow keys jump to the edge of a data range, while Control Home moves to cell A1. Understanding these basic navigation techniques ensures you can quickly access and modify any part of your data without unnecessary scrolling. Efficient navigation saves time and reduces errors, especially when dealing with extensive spreadsheets. Switching between different worksheets within a workbook is done by clicking on their respective tabs at the bottom of the Excel window. You can also use Control Page Up or Control Page Down to cycle through sheets. To move between different workbooks, use Alt-Tab to switch between open applications or go to the View tab and select Switch Windows. Managing worksheets involves actions like adding new sheets, deleting existing ones, renaming them, and changing their tab color for better organization. These actions help in structuring your data logically, making your Excel files more manageable and easier to understand for both yourself and collaborators. Entering and editing data. Entering data into Excel cells is the most fundamental operation. You can type directly into an active cell and press Enter to move down, Tab to move right, or use arrow keys to navigate. Excel supports various data types, including numbers, text, dates, and times, automatically recognizing the type in most cases. For numerical data, you can enter integers, decimals, and percentages. Text data can include any alphanumeric characters. Dates and times are entered in standard formats, and Excel converts them into serial numbers for calculations. Understanding how to correctly input different data types is crucial for accurate analysis and calculations within your spreadsheets. Editing existing data is equally important for maintaining accurate records. To edit cell content, you can double-click the cell, press F2, or click within the formula bar. This allows you to modify specific characters or values without retyping the entire entry. When editing, the insertion point appears, enabling precise changes. After making edits, press Enter to confirm or Escape to cancel. You can also clear cell contents by selecting the cell and pressing Delete. These editing techniques ensure flexibility and precision in managing your data, allowing for quick corrections and updates as your information evolves. Selecting and moving data. Selecting data efficiently is a foundational skill in Excel, enabling you to apply formatting, perform calculations, or move information. You can select a single cell by clicking it, arrange adjacent cells by clicking and dragging, or non-adjacent cells by holding Control while clicking. To select an entire row, click its row number. For an entire column, click its column letter. Selecting large ranges can be done quickly by clicking the first cell, holding Shift, and clicking the last cell in the desired range. These selection methods are critical for applying operations to specific parts of your spreadsheet, ensuring accuracy and control over your data. Moving data within Excel allows you to reorganize your spreadsheet layout. The cut and paste commands Ctrl-X and Ctrl-V are used to move selected cells or ranges to a new location. When you cut data, it is temporarily stored on the clipboard until pasted. Alternatively, you can drag and drop selected cells by hovering the mouse over the border of the selection until the cursor changes to a move icon, then dragging it to the new position. Holding Shift while dragging inserts the cut cells and shifts existing cells, rather than overwriting them. These techniques provide flexibility in arranging your data, adapting your spreadsheet to evolving analytical needs. Finding and replacing data. Finding specific data within large Excel spreadsheets is a common task, especially when dealing with extensive datasets. The Find feature, Ctrl-F, allows you to search for text, numbers, or even specific formatting across your entire workbook or a selected range. You can specify search options such as matching case, searching within formulas or values, and searching by rows or columns. This tool is invaluable for quickly locating particular entries, saving significant time compared to manual scanning. It helps maintain data integrity by ensuring you are working with the correct information, preventing errors that can arise from misidentified data points. The Replace feature, Ctrl-H, extends the functionality of Find by allowing you to automatically substitute found data with new content. This is particularly useful for correcting consistent errors, updating outdated information, or standardizing data entries across a large dataset. You can choose to replace all instances at once or review and replace them one by one. Similar to Find, Replace offers options for matching case and searching within specific areas. Both Find and Replace are powerful tools for data cleaning and management, ensuring consistency and accuracy throughout your Excel files, which is critical for reliable analysis and reporting. Using autofill and custom lists, autofill is a highly efficient feature in Excel that automatically completes data series or patterns, saving significant time and reducing manual entry errors. When you enter a pattern, such as January or 123, Excel can intelligently extend that series. Simply drag the fill handle, a small square at the bottom right corner of the active cell, across the desired range, and Excel will populate the cells accordingly. This works for numbers, dates, days of the week, and even custom series you define. Autofill is particularly useful for creating sequential lists, filling in repetitive data, and generating date ranges, streamlining data input for various tasks. Custom lists allow you to define your own autofill series, which is incredibly useful for specific sequences not built into Excel. For example, you can create a list of department names, employee IDs, or product categories that you frequently use. Once a custom list is created, via File, Options, Advanced, Edit Custom Lists, Excel will recognize the first item in your list and extend the series when you use the fill handle. This feature ensures consistency in data entry and eliminates the need to repeatedly type out common sequences. Custom lists are a powerful tool for standardizing data and enhancing productivity in specialized Excel applications. Basic arithmetic formulas. Formulas are the core of Excel's power, enabling calculations and data manipulation. All formulas in Excel begin with an equals sign, equals. This tells Excel that the cell contains a calculation, not just data. Basic arithmetic formulas use operators like addition, plus, subtraction, minus, multiplication, and division. For example, equals A1 plus B1 adds the values in cells A1 and B1. Understanding operator precedence, PEMDAS, BODMAS, is crucial. Multiplication and division are performed before addition and subtraction, unless parentheses are used. Mastering these fundamental formulas is the first step towards leveraging Excel for complex data analysis and problem solving, providing immediate insights from raw numbers. Cell references are integral to formulas, allowing calculations to dynamically update when underlying data changes. Instead of typing specific values, you refer to the cells containing those values. This makes your spreadsheets flexible and reusable. For instance, if you have sales figures in column B and expenses in column C, you can calculate profit for each row using a formula like equals B2 minus C2. When copied down, this formula automatically adjusts to equals B3 minus C3, equals B4 minus C4, and so on. B4 minus C4, and so on. This dynamic referencing is what makes Excel so powerful for creating scalable and adaptable financial models, budgets, and analytical reports, ensuring accuracy across large datasets. Understanding cell references, relative, absolute, mixed. Cell references are fundamental to creating dynamic and flexible formulas in Excel. By default, Excel uses relative references, meaning that when a formula is copied to another cell, the references automatically adjust based on the new position. For example, if equals A1 plus B1 in C1 is copied to C2, it becomes equals A2 plus B2. This behavior is incredibly useful for applying the same calculation logic across many rows or columns without manual adjustment. Understanding relative references is key to building scalable spreadsheets where formulas adapt to their new context, making your work more efficient and less prone to error when dealing with large datasets. Absolute references, denoted by dollar signs, lock a cell reference so it does not change when copied. For example, equals $A will always refer to cell A1, regardless of where the formula is copied. This is essential when a formula needs to refer to a constant value, such as a tax rate or a fixed discount, that is located in a specific cell. Mixed references combine both relative and absolute components, locking either the row or the column. Example, equals A1 locks column A. Add $A locks row 1. These different reference types provide precise control over how formulas behave when copied, allowing for sophisticated calculations and flexible spreadsheet design. Common functions sum, average, count, min, max. Excel functions are predefined formulas that perform specific calculations, simplifying complex operations. They save time and reduce errors compared to manual calculations. The sum function adds all numbers in a specified range, for example, equals sum A1 to A10. The average function calculates the arithmetic mean of a range of numbers. like equals average B1, B10. These functions are essential for quickly summarizing large datasets, providing immediate insights into totals and central tendencies. They are widely used in financial analysis, statistical reporting, and general data aggregation, making them indispensable tools for any Excel user seeking efficient data summarization. The count function tallies the number of cells in a range that contain numbers, useful for determining dataset size, e.g. equals count C1 to C10. The min function finds the smallest number in a range, while the max function identifies the largest, for instance, equals min D1 to D10 and equals max E1 to E10. These functions are crucial for identifying extremes and understanding the range of values within your data. Together, sum, average, count, min, and count, and max form a core set of functions that every Excel user should master. They provide powerful capabilities for basic statistical analysis and data exploration, enabling quick assessments of data characteristics. Logical functions, if, and, or. Logical functions in Excel allow you to perform conditional tests on your data, enabling decision-making within your spreadsheets. The if function is the most common, allowing you to specify a condition and return one value if the condition is true, and another if it's false. Its syntax is equals if logical test value if true, value if false. For instance, equals if A1 greater than 100, high, low, categorizes values based on a threshold. This function is invaluable for creating dynamic reports, categorizing data, and automating responses based on specific criteria. Mastering the if function opens up possibilities for sophisticated data analysis and automated decision logic within Excel. Formatting cells and ranges. Formatting cells and ranges in Excel enhances readability and helps highlight important data. You can apply various formatting options, including changing font type, size, color, and applying bold, italic, or underline styles. Alignment options allow you to position text within cells, left, center, right, top, middle, bottom, and control text wrapping or merging cells. These visual adjustments make your spreadsheets easier to understand and more professional in appearance. Effective formatting guides the viewer's eye to key information, improving the overall clarity and impact of your data presentations, which is crucial for effective communication. The Format Cells dialog box, Control 1, provides comprehensive control over cell appearance, offering tabs for number, alignment, font, border, fill, and protection. Borders can be added to cells or ranges to create visual separation, and fill colors can highlight specific areas. Cell styles, found on the Home tab, offer predefined combinations of formatting options, ensuring consistency across your workbook. Using consistent formatting not only makes your data look better, but also makes it more navigable and understandable. Proper formatting is a key aspect of creating professional and effective Excel reports and dashboards, allowing for clear and impactful data communication. Conditional formatting. Conditional formatting is a powerful Excel feature that automatically applies formatting to cells based on specified conditions. This allows you to visually highlight important data, identify trends, and spot anomalies at a glance. For example, You can set rules to automatically color cells red if their value is below a certain threshold, or green if above. Conditional formatting can be applied using various criteria, such as cell values, text content, dates, or even formulas. It transforms raw data into a visually intuitive representation, making it much easier to interpret and analyze complex information, which is invaluable for quick decision-making. Excel offers several types of conditional formatting rules, including highlight cells rules, e.g. greater than text that contains, top-bottom rules, e.g. top 10 items below average, data bars, visual bars within cells representing values, color scales, gradients of color based on value distribution, icon sets, graphical icons like arrows or traffic lights. These tools provide a dynamic way to visualize data patterns and exceptions without manually applying formatting. Conditional formatting is widely used in dashboards, reports, and data analysis to draw attention to critical information, enabling users to quickly grasp key insights and take appropriate action. Number formatting and styles. Number formatting in Excel controls how numerical values are displayed without changing their underlying value. This is crucial for presenting data clearly and consistently. You can apply various formats such as currency, percentage, date, time, scientific, or custom formats. For example, applying currency format to a cell containing 1234.56 will display it as $1234.56. This ensures that financial data looks like currency, dates appear as dates, and percentages are clearly identified. Proper number formatting enhances the professional appearance of your spreadsheets and prevents misinterpretation of data, making your reports more accurate and easier to read. Beyond basic number formats, Excel offers advanced options and cell styles to streamline formatting. Custom number formats allow you to define your own display rules, including text, symbols, and conditional formatting within the format itself. Cell styles are predefined sets of formatting options, font, color, borders, number format, that can be applied with a single click. Excel includes built-in styles for headings, totals, and good, bad, neutral indicators. You can also create your own custom cell styles to maintain brand consistency or specific reporting requirements. Using styles ensures uniform formatting across your workbook, saving time and improving the overall aesthetic and readability of your data. Creating basic charts. Charts are powerful visual tools in Excel that transform raw data into easily understandable graphical representations, making trends and patterns immediately apparent. To create a basic chart, you first select the data range you want to visualize. Then, navigate to the Insert tab on the ribbon and choose from the Charts group. Excel offers a variety of chart types suitable for different data stories. The Recommended Charts feature can suggest appropriate chart types based on your selected data, simplifying the selection process. Creating charts is a fundamental skill for data analysis, as it allows for quick interpretation and communication of insights. Once a chart is inserted, Excel automatically places it on the same worksheet as your data, or you can move it to a new chart sheet. Basic charts typically include a title, axis labels, and a legend. You can quickly adjust these elements using the Chart Elements button plus that appears next to the chart, or by using the Chart Design and Format tabs on the ribbon. These contextual tabs appear only when a chart is selected, providing tools for customization. Even a simple bar or column chart can reveal significant trends or comparisons that might be hidden in a table of numbers, making charts indispensable for effective data storytelling. Chart types and their uses. Excel offers a diverse range of chart types, each best suited for visualizing specific kinds of data and conveying particular messages. Column and bar charts are excellent for comparing values across different categories. Line charts are ideal for showing trends over time, such as sales performance across months or years. Pie charts represent parts of a whole, illustrating proportions or percentages of a total. Understanding when to use each chart type is crucial for effective data communication, as the wrong chart can obscure insights or mislead the audience. Selecting the appropriate chart ensures your data story is told clearly and accurately, maximizing its impact. Other specialized chart types include area charts, which emphasize the magnitude of change over time, and scatter plots, used to show the relationship between two numerical variables. Combination charts allow you to plot different data series using different chart types on the same graph. For example, a column chart for sales and a line chart for profit margin. Radar charts compare the aggregate values of several data series. Excel 2019 also introduced new chart types like funnel and map charts, expanding visualization capabilities. Familiarity with these various options empowers you to choose the most effective visual representation for any dataset, enhancing your analytical presentations. Customizing chart elements. Customizing chart elements is essential for making your visualizations clear, professional, and impactful. After creating a chart, you can modify its title, axis labels, legend, data labels, and grid lines. The Chart Elements button, located next to the chart, provides quick access to toggle these components on or off. You can also right-click on any chart element to access specific formatting options, allowing for precise control over its appearance. Customization ensures that your chart effectively communicates its message without ambiguity, making it easier for your audience to understand the insights presented. Thoughtful customization enhances both the aesthetic appeal and the analytical clarity of your charts. Beyond basic elements, you can customize the chart's data series, plot area, and chart area. This includes changing colors, adding patterns, adjusting line thickness, and applying effects. The Chart Design and Format tabs on the ribbon provide extensive tools for these modifications. You can also add trend lines to show data patterns, error bars to indicate uncertainty, or spark lines for miniature charts within cells. Customizing these elements allows you to tailor your charts to specific reporting needs and brand guidelines. Effective chart customization transforms standard visualizations into compelling data stories, making your presentations more engaging and persuasive. Sparklines and data bars. Sparklines are tiny charts placed within a single cell, providing a quick visual summary of data trends without taking up much space. They are excellent for showing patterns like seasonal increases or decreases or volatility directly alongside the data they represent. Excel offers 3 types of sparklines: line, column, and win-loss. You can insert them from the Insert tab, specifying the data range and the location for the sparkline. Sparklines are particularly useful in dashboards and reports where space is limited but visual trend indicators are needed. They offer immediate context to numerical data, making it easier to spot trends at a glance. Data bars are another form of in-cell visualization that represent the value of a cell using a colored bar within the cell itself. They are a type of conditional formatting where the length of the bar corresponds to the cell's value relative to other values in the selected range. Data bars are effective for quickly comparing values across a range, such as sales figures for different products or performance metrics. They provide an intuitive visual cue about magnitude, making it easy to identify the highest and lowest values. Both sparklines and data bars enhance data readability and analysis directly within the spreadsheet grid, offering powerful visual insights without the need for full-size charts. Introduction to pivot tables. Pivot tables are one of Excel's most powerful features for summarizing, analyzing, exploring, and presenting large amounts of data. They allow you to quickly transform rows of raw data into meaningful reports by categorizing and aggregating information. Instead of manually sorting and filtering, a pivot table enables you to drag and drop fields to instantly reorganize and summarize data from different perspectives. This dynamic capability makes it an indispensable tool for business intelligence, financial analysis, and data exploration. Understanding pivot tables unlocks a new level of analytical power within Excel, allowing you to derive insights from complex datasets with ease. The primary purpose of a pivot table is to take detailed data and present it in a summarized, aggregated format. For example, from a list of individual sales transactions, you can quickly create a pivot table to show total sales by region, by product, or by salesperson. This process involves defining rows, columns, values, and filters for your data. The flexibility to change these arrangements on the fly is what gives pivot tables their pivot name. They are non-destructive, meaning they don't alter your original data, and they can be refreshed to incorporate new data. Pivot tables are crucial for creating dynamic reports and dashboards, providing actionable insights from vast amounts of information. Creating and modifying pivot tables. Creating a pivot table begins with selecting your source data, which should ideally be structured as a clean tabular range with clear headers. From the Insert tab, click Pivot Table. Excel will prompt you to confirm the data range and choose where to place the pivot table: New Worksheet or Existing Worksheet. Once created, the Pivot Table Fields pane appears, allowing you to drag fields into 4 areas: rows, columns, values, and filters. Fields dragged to values are automatically aggregated. Example, summed, counted, averaged, providing the core of your summary. This initial setup is crucial for defining the structure and content of your analytical report. Modifying a pivot table involves rearranging fields, changing aggregation types, and applying filters. You can drag fields between the rows, columns, values, and filters areas to instantly change the data's perspective. For example, moving region from rows to columns will display regions horizontally. To change the aggregation, for example from sum to average, right-click on a value field in the pivot table and select Value Field Settings. Filters allow you to narrow down the data displayed, showing only specific categories or values. These modification capabilities make pivot tables incredibly flexible for exploring data from multiple angles, enabling dynamic reporting and in-depth analysis without altering the original dataset. Introduction to pivot charts. Pivot charts are dynamic graphical representations of data in a pivot table. They are linked directly to a pivot table, meaning that any changes you make to the pivot table, like filtering, adding fields, or changing aggregation, are automatically reflected in the pivot chart. This dynamic linkage makes pivot charts incredibly powerful for interactive data visualization and exploration. They allow you to quickly create professional-looking charts that adapt to different views of your data, providing immediate visual insights into trends and patterns. Understanding pivot charts is crucial for anyone who needs to visually communicate complex data summaries effectively. To create a pivot chart, first select any cell within an existing pivot table. Then go to the Analyze tab under Pivot Table Tools and click Pivot Chart. Excel will present a dialog box with various chart types similar to regular charts. Once created, a pivot chart functions much like a regular chart, but includes pivot chart field buttons that allow for interactive filtering and drilling down into data directly from the chart. This interactivity makes pivot charts ideal for dashboards and presentations where users need to explore data dynamically. They are an essential tool for transforming summarized data into compelling and flexible visual stories. Managing worksheets. Effective worksheet management is crucial for organizing complex Excel workbooks and ensuring data clarity. You can add new worksheets by clicking the plus button next to the Sheet tabs or by using Shift F11. Worksheets can be renamed by double-clicking their tab or right-clicking and selecting Rename. For better visual organization, you can change the tab color of worksheets, making it easier to distinguish between different sections of your workbook. These basic management tasks help in structuring your data logically, preventing clutter, and improving overall navigability within your Excel files, especially when dealing with multiple data sources or reports. Beyond adding and renaming, you can also move, copy, and delete worksheets. To move a sheet, simply click and drag its tab to a new position. To copy a sheet, hold Ctrl while dragging its tab. Deleting a sheet is done by right-clicking its tab and selecting Delete, but be cautious, as this action is permanent. You can also hide and unhide sheets to temporarily remove them from view without deleting their data. These advanced management techniques provide flexibility in structuring your workbook, allowing you to organize data, reports, and calculations in a way that best suits your project's needs, enhancing collaboration and ease of use. Linking data across worksheets and workbooks. Linking data across different worksheets and workbooks is a powerful feature in Excel that allows you to consolidate information and create dynamic reports. You can reference a cell or range from another worksheet within the same workbook by including the sheet name in the formula. For example, equals sheet 2 A1. This ensures that if the data on sheet 2 changes, the linked cell on your current sheet automatically updates. This capability is essential for building summary sheets that pull data from various detailed input sheets, maintaining data integrity and consistency across your entire project. It streamlines reporting processes and reduces manual data entry errors. Linking data between different workbooks extends this functionality, allowing you to pull information from separate Excel files. The formula for linking to another workbook includes the workbook name in square brackets, the sheet name, and the cell reference, like equals salesdata.xlsx sheet 1 A1. For external links to work, the source workbook must be open or its path must be specified if it's closed. This feature is invaluable for creating master dashboards that consolidate data from multiple departmental files or for building complex financial models that span several linked documents. Linking data across workbooks ensures that your reports are always up to date, reflecting the latest information from all relevant sources. Introduction to macros. Macros are a powerful feature in Excel that allow you to automate repetitive tasks, saving significant time and reducing the potential for human error. A macro is essentially a series of commands and actions that Excel records or can then replay on demand. This automation is particularly useful for tasks that you perform frequently, such as formatting reports, importing data, or generating specific calculations. By automating these processes, macros free up your time to focus on more analytical and strategic work. Understanding the basics of macros is the first step towards transforming your Excel workflow into a highly efficient and streamlined operation. Macros are built using Visual Basic for Applications, VBA, a programming language integrated within Excel. While you can write VBA code directly, the easiest way to create a macro is by using the Record Macro feature. This feature records your mouse clicks and keystrokes, translating them into VBA code behind the scenes. Once recorded, the macro can be assigned to a button, a keyboard shortcut, or run from the macros dialog box. Macros are stored within the workbook and can be shared with others, making them a valuable tool for standardizing processes and improving productivity across teams. They represent a significant leap in Excel proficiency, moving beyond manual operations to intelligent automation. Recording and running macros. Recording a macro is the simplest way to automate tasks in Excel without needing to write code manually. To begin, ensure the Developer tab is visible on your ribbon. If not, enable it via File, Options, Customize Ribbon. Click Record Macro in the code group. A dialog box will appear asking for a macro name, a shortcut key, optional, and where to store the macro. Once you click OK, Excel starts recording every action you perform. It's crucial to perform only the necessary steps during recording to keep the macro clean and efficient. Every click, keystroke, and menu selection is translated into VBA code, capturing your workflow precisely. After performing all the desired actions, click Stop Recording on the Developer tab. Your macro is now saved. To run a recorded macro, you can use the assigned shortcut key. Click Macros in the Developer tab and select your macro from the list, or assign it to a button on your worksheet. Running a macro executes the recorded sequence of commands, instantly replicating the automated task. It's important to test your macros thoroughly to ensure they perform as expected and handle different scenarios correctly. Recording and running macros are fundamental skills for anyone looking to significantly enhance their efficiency and automate routine operations in Excel, transforming manual work into quick, repeatable processes. Understanding basic VBA for macros. While recording macros is a great starting point, understanding basic Visual Basic for applications, VBA, allows you to customize and enhance your recorded macros, or even write new ones from scratch. VBA is the programming language that powers Excel macros. You can access the VBA editor by pressing Alt F11. Here, you'll see modules where your macro code resides. Each recorded macro translates into a sub-procedure containing lines of code that represent your actions. Familiarizing yourself with basic VBA syntax, such as range A1.select or ActiveCell.value equals hello, helps you understand and modify the automated steps. This foundational knowledge empowers you to troubleshoot and refine your macros beyond simple recording. Key VBA concepts include objects like workbook, worksheet, range, properties, attributes of objects, example, range A1 value, and methods, actions objects can perform, example, range A1 select. Variables are used to store data temporarily, and control structures like if-then-else statements or for-next loops allows the conditional logic and repetition. Even a basic grasp of these concepts enables you to make minor adjustments to recorded macros, such as changing a cell reference or adding a message box. This level of understanding transforms you from a macro recorder to a macro editor, significantly expanding your automation capabilities and problem-solving skills within Excel.